Absolute value inequalities are solved pretty much the same way as their equations, but we have to keep in mind a few things because the inequality brings rise to a couple of issues. First off, distances are always a zero or positive. It cannot be negative. Keep this in mind. So now let a be a real number that's greater than zero. Now, for this first one, if the absolute value of x is greater than a, some number, then we're asking what are all the numbers that are more than a units away. So if a was 2, then the answer would be less than -2 and greater than +2. Those are all the numbers that are 2 units away or more. Well, I should say 2 units more away from 0. Now this is the same idea as the absolute value of x greater than or equal to a. This is all the numbers except now you can have it equal to a. So negative a and greater than a. So this is the same thing as the union between this, x less than the negative, x greater than the positive, x less than or equal to the negative or greater than the positive. So keep this in mind. You're looking at, think of the absolute value like a circle, and this is really asking what's outside of that circle, everything on the outside. So it goes off in infinitely many directions, and it's a lot of stuff. That's the idea here. Now for this next one, we're going to go down. This is the absolute value of x less than a, or the absolute value of x less than or equal to a. So this is everything on the inside of that circle. Or if it's equal to, it can be on the circle as well. This is the same thing as this compound inequality with the 3 parts, or if it's greater than or equal to. Okay, now with this in mind, we've talked about when the absolute value is greater than some positive number or less than some positive number. What about if we have greater than or less than some negative number? This one says all numbers that are greater than some negative number or greater than or equal to some negative number. All numbers more than, bigger than, or equal to a negative distance away. And every distance is either 0 or positive. But 0 and positive numbers are always greater than a negative number. Therefore, every distance satisfies this inequality. All distances can be satisfied, so there's infinite solutions. So whenever you see this, whenever you have this situation, you can say, well, there's infinite solutions. On the flip side, if we look at negative distances that are less than some negative number, or less than or equal to some negative number, all distances are 0 or positive, so no distance can be less than a negative number because 0 or positive are always greater than negative numbers. So there are no solutions. This is not possible. Okay, so when we're working with this situation, we're going to get the absolute value by itself. You can see for all these situations, we have the absolute value of x on the left-hand side. It's just by itself. So that's the first thing we're going to do here. So for this first problem, let's add 5 to the absolute value of 3x minus 1 greater than or equal to 12. Then divide by 2. Okay, this is a positive number, so we know there are going to be 2 valid solutions. It's not greater than or less than some negative number. So we don't have those weird cases. Now, this is how you solve this equation. We're going to break this up into 2 equations. The first one's going to be the exact same thing, 3x minus 1 greater than or equal to 6. And the next equation is going to be, we're going to give the 6 a negative sign, but think of it like multiplying by a negative. Whenever you multiply by a negative, you must flip the inequality. So we're going to get this equation and 3x minus 1 less than or equal to negative 6. Okay, with this in mind, we can solve this. It's just solving a normal linear equation, divide by 3. We get x greater than or equal to 7/3. The same process, add 1, then divide by 3. We're going to get x less than or equal to, this is going to be -5, so -5/3. So this is the restriction we get for our inequality. Now, once again, this situation was an absolute value greater than, that's fitting this one here. So we have this union between two inequalities. So really we should say it's the union between these two. That's the solution set, the feasible region. Okay, for this next one, we're going to divide by 3. We have -2/3 less than or equal to the absolute value of x plus 5. This absolute value is greater than a negative number. All distances are greater than a negative number. Therefore, there are infinite solutions. And we can stop right there. Okay, let's actually graph this thing to give you an idea. So this first one here, I'm going to graph this left-hand side and then y equal to 7 for the right-hand side. And we're asking, the solution is where one relation is above, below, or at the other. That depends on what we're looking at here. So we're asking, when is this left-hand side portion, when is this greater than or equal to 7? In other words, when is it bigger or higher up? When is it above 7? Well, 7 is the blue line here, and the red line is 2x, is this absolute value portion. That's this graph here. So we're asking, when is this thing greater than or above the blue line? That happens on this portion of the domain and this portion of the domain. That's going to be at, this number is, I believe, -5/3. And this one is at, looks like 7/3. Is that right? Yeah, 7/3 and -5/3. X less than or equal to -5/3. X less than that, it's going to be this portion of the domain. That's when this function is greater than. And when x is greater than or equal to 7/3, greater than or equal to 7/3 is this portion of the domain, which goes to this portion of the graph. So that is correct. If you were to actually graph the inequality, you're going to see it's going to give you these two bars, and it's going to shade this portion and this portion. This central region is not feasible. Of course, these are at -5/3 right here in this way, and then 7/3, x greater than 7/3, which is this portion here. So that's accurate to the graph. Okay, for the next one, we had infinite solutions. So if we look at the graph, you can see that this is the graph we have, and we're asking, when is the absolute value function greater than or equal to -2? So when is it above -2? -2 is right here, and when is this function above that? It's above it everywhere. It's always above it. It just keeps going upward, both to the left and to the right. It never touches it or goes below it at all. So everything is the solution. There's infinite solutions. Everything on the x-axis from -infinity to infinity is the solution. And that's shown here as Desmos is going to shade everything. The entire graph gets shaded. There's no spot that's missing here. So that's how Desmos shows that, with infinite solutions. Okay, give it a try in number 2. Now, absolute values are a great tool for showing error measurements, because we're looking at what's both above and below a certain central point, and that's what absolute value really shows. So here we have a machinist is producing bearings that must be within a 0.01 inch tolerance. The correct diameter is 5 inches, and so we want to be no more than 5.1 inches and no less than 4.9. That's the, 5.01 inches and 4.99 inches. That's the tolerance here. So we're between 4.99 and 5.01. Okay, using x as the diameter of the bearing, so x is what's been produced. We're going to use a statement of absolute value to show what the situation is. So the absolute value shows the distance between something, the actual diameter that we're producing, that's what x is, and the correct diameter is 5. Like I'm going to go x minus 5 here. This is saying the distance between the correct diameter, which is 5 inches, and the actual diameter, the thing that we produced, which is x inches, the distance, which is the absolute value of x minus 5, or the absolute value of 5 minus x, it's the same thing. That distance must be within or less than or equal to this error tolerance. And that's the absolute value equation, or in this case, an inequality, that models this scenario. I can solve it by getting the breaking up the absolute value, and then it's going to be x minus 5 greater than or equal to negative 0.01. Then all I have to do is add 5. And you can see here from this one, we get x must be less than or equal to 5.01. And x must be greater than or equal to 4.99. And that means that we are in this tolerance range. So we have here we're going to put 4.99. We're going to zoom in quite a bit. 5.01. X must be less than or equal to it. That's going to be this. X must be greater than or equal to 4.99. And everything between is what we're looking for. That's the solution. And that fits exactly what we had said before. That's what this is. So this equation here, or this inequality, models the situation perfectly. Okay, give it a try in number 3.